We have heard about similar triangles, right? How do we understand them? By definition, two triangles are said to be similar if their corresponding angles are congruent and the corresponding sides are in proportion. So these two triangles you see on the screen are similar triangles. But what's a simple way to understand similar triangles? We can simply think of it as zooming in or zooming out, making the triangle bigger or smaller. If we zoom in or zoom out, the basic shape remains the same. But have you ever constructed a similar triangle? Sounds interesting, right? Let's see how we construct a triangle similar to a given triangle. But before that, we need to understand something called the scale factor. In simple terms, scale factor is the ratio of the sides of the triangle to be constructed to the corresponding sides of the given triangle. Say we have triangle ABC here. And we draw a triangle PQR similar to this triangle. So here, these three ratios will be the scale factor. Remember, it's the ratio of the sides of the triangles to be constructed to the sides of the given triangle. There's another way to look at this. If we have to measure PQ, we simply look at it as AB times the scale factor. If we have to measure QR, we can look at it as BC times the scale factor. And it's similar for RP. Let's understand this better with the help of an example. Here it is. This scale factor 3:4 or 3/4 tells us something. It tells us that the ratios of the sides of the triangle to be constructed to the sides of the given triangle are all equal to 3/4. It tells us that we are required to construct another triangle whose sides are 3/4 times the respective sides of the triangle ABC. This also tells us that the similar triangle to be constructed will be a scaled-down version of the original triangle. Let's start our construction by drawing a triangle ABC having sides of the given lengths 3 cm, 4 cm and 5 cm. Here's how the triangle will look. How do we construct a similar triangle with this scale factor now? Firstly, we draw ray BX from the point B, making an acute angle with the side BC. Note that this angle has to be acute. Now, have a close look at the scale factor here. Can you tell me which of the numbers is greater, the numerator or the denominator? Yes, it's the denominator, which is 4. The greater number among the numerator and the denominator will give us the number of equal parts we mark on ray BX. Here, we draw 4 equal parts. How? We adjust the compass to any width and place it on point B. Draw an arc on ray BX and mark this point as B1. Now, keep the compass on point B1 and draw another arc at the same distance. Yes, we need to keep the width of the compass the same. Mark this point as B2. Likewise, we will mark 2 more points, B3 and B4. Now, what will be our next step? We will join the points B4 and C. Next, let's have a look at the scale factor once again. This time, tell me which of the numbers of the numerator and the denominator is the smaller one? Yes, it's the numerator, which is 3. As the small one is 3, we take the third point, which is B3, and draw a line parallel to B4C. We mark this point as C prime. Can you tell me what we did here? Yes, we divided segment BC in the ratio 3:1. We can also say that BC prime is 3/4 times BC. So BC prime is one of the sides of the similar triangle we are aiming to construct. So what next? We will draw a line from point C prime parallel to side AC. We mark this point as A prime. Guess what? We have our similar triangle. The triangle A prime B C prime is the required triangle. It's similar to triangle ABC and with a scale factor of 3:4. Let's verify our construction. Have a look at this side, BC prime. This side comprises of 3 parts on BX. This one this one and this one. Now look at the side BC. How many parts does this comprise of? Yes, it's 4 parts. So, can we say that these two sides are in a ratio of 3 to 4? Of course we can. Even if you compare these two lengths or these two lengths, we will get a ratio of 3 to 4. Hence, our construction is verified. This is how we construct a triangle similar to a given triangle. But I have one interesting question for you. What if our scale factor was 4 over 3 rather than 3 over 4? How would we construct this one? What would be the changes in the construction? Tune into our next lesson to see how it's done.